Morning, everyone. I appreciate the opportunity to speak here today. There's been a lot of interesting talks so far. Thank you, Steve, for a lot of new and positive spin on things there. You're more positive today than I've seen you at other times. So today, as it's just stated, I'm going to talk about the status of forage fish or prey fish in Lake Michigan. And basically the talk is going to be one that some of you have seen before. And I'll kind of try and introduce this by highlighting the fact that the Lake Michigan ecosystem has undergone a lot of changes, a lot of degradation, I would call it. The invasive species that are present have really exerted a major influence on the lake, and I don't think we're really even close to understanding the full extent of these impacts. We've seen pretty major decreases in chlorophyll and primary production. We've seen, in some cases, as Steve mentioned, no change in organisms we would expect to see changes in that follow changes in fish biomass. We have some key native species that are gone or nearly gone. I don't think we really have a good handle on what that means to any great extent. Things like kai, the loss of offshore vertical migration, what does that mean to this lake? I don't think we have a good handle on that. We know that based on a number of efforts over the past few years that the prey fish biomass is well below the FCO. So overall, it's a pretty dynamic situation. We know that prey fish are pretty important for a number of reasons, whether it be commercial fishing in the past or perhaps even as prey for some of these important predators. We know that Chinook are heavily reliant on alewife. Alewife are also pretty key in the diet of a number of other species, including lake trout. We also know that a lot of species in Lake Michigan, as well as some of the other lakes, are utilizing round goby. These organisms, these fish, are pretty important for the food web. They serve as a conduit many times for energy at lower trophic levels to make it through zooplankton and through these fish to predators. And they have the capability, by influencing the zooplankton community, to drive some of the nutrient dynamics and grazing dynamics in the food web as well. So today's talk, I'm going to talk a little bit about the methodology. Then I'm going to go into temporal patterns in the species that we're going to talk about. First, it'll be species that are common to both our acoustic survey and bottom trawl survey. And then I'll focus on benthic fish that are primarily from the bottom trawl survey. A little bit of information about goby and goby status and goby uncertainties. I'll try to put the Lakewide surveys in some context, and then I'll present some conclusions. To talk about methodology, we have two Lakewide surveys that happen. The bottom trawl survey has been happening for a long time. That's something that's carried out by USGS. It happens during the day. It covers just under 70 sites, spans bottom depth of 9 to 110, and now we're moving it to 128 meters bottom depth. And it catches some species that are also common to the acoustic survey, like alewife, bloater, and rainbow smelt. We have the acoustic survey, which is done at night. It's been done at night for a number of reasons, but one of the key ones is if you want to use acoustics to estimate fish density or biomass, the fish need to be dispersed in the water column. They can't be schooled if you want your best accuracy. It is possible to estimate biomass from schools, but it's just not as effective in many cases. We sample a broader portion of the lake. We have a spatial coverage, a bottom depth coverage that's a fair bit greater than the bottom trawl survey. You can see in the maps that are present on the left-hand side the locations that are sampled in the bottom trawl survey, the right-hand side those locations in the acoustic survey that have been sampled since I think 2004. And in addition to the species that are common to the bottom trawl survey, we also can get Cisco and emerald shiner, things that are rarely, if ever, captured in the bottom trawl survey. So I'm going to move very quickly into the time series data. This plot is one that is going to be shown throughout this talk. We have two plots here. One panel is the time series with the black line corresponding to the 1992 to 2009 period, and the magenta line corresponding to the 2010 to 2015 time period. And on the right panel, you see a box plot that just shows the mean, median, and confidence intervals for the data making up the two lines in the left panel. We can see there's a lot of variability in this time series for young of year alewife, and if I had made the decision to not include 2010 in this magenta line, things would probably look a fair bit different in the box plot. But ultimately, there's enough variability in these time series that you really can't say that there's been a drastic change in these two time periods. As far as the larger, older alewife, this is yearling or older alewife, we see that we had pretty high biomass levels, 95 and 96, and pretty major decrease from those levels in the early 2000s up through 2008, 2009. We saw an increase in biomass, but really what we see is, in spite of overlap between the confidence intervals in these box plots, a lot less variability in recent years. Bottom trawl survey can maybe give us a better sense of things because it's a longer time series. And you can see that there's also a lot of variability present in that time series. Looking at the confidence intervals in the box plot on the right, you'd say, well, they're no different, but I would argue they are pretty different. Looking at the medians and looking at just the spread in those distributions, it's really pretty striking in my mind. As far as rainbow smelt, we've seen something somewhat similar, a little bit more drastic in the acoustic survey. We've got a paper out there that looked at this just from the midwater trawl perspective, and basically what we're seeing is a shift from the late 80s, early 90s, a rainbow smelt bloater-dominated system to one that's dominated by alewife, with the decline in both bloater and rainbow smelt. We really are getting hardly any rainbow smelt in this survey. They're still holding on in Green Bay to some extent, thanks to the efforts of Fish and Wildlife Service. We know that, but overall they're much, much lower than they used to be. The same can be said from the bottom trawl survey data. This shows a pretty drastic decrease from the early 1990s to present, and every year we go out, we jokingly say, is it going to get even lower? And it does. We've not reached the point of not catching any yet, though. Acoustic biomass density of bloater is another similar picture. Much higher biomass density in the 1990s based on the acoustic survey data than what we see presently. There's enough variability that it makes it tough to argue there's a statistically significant difference, but in my mind, it's a biologically significant difference, and I don't think anyone is likely to argue otherwise. See the same thing, and perhaps even more striking picture of that with the bottom trawl survey. In the late 1990s to 2000s, we've just really not had much in the way of significant recruitment to offset mortality. We have had recruitment events. We have had, decent year classes, what I would call decent year classes anyway of bloater. In 2015, we saw the third highest density of small bloater that we've seen in the acoustic time series, but they were tiny fish. In August, they were 20 to 30 millimeters long. So I really don't know how they're doing, and if they're out there serving as a prey buffer for alewife, they're not going to be very successful in making it to larger sizes. So now we're going to talk about some of these benthic species that we only get in the bottom trawl survey, and you can see even though there's a lot of variability in the most recent time period, what I'll call my measure of the reporting period for the state of the lake, pretty consistent decline, and we're now at the lowest levels of slimy sculpin ever observed in the survey. Because of the variability in these two time periods, though, statistically speaking, we can't detect a difference. We can also see that in spite of some of the food web changes in the lake, we had a period of very high slimy sculpin biomass density in 2005. Even up through 2008, we see, or 2009, we see the biomass densities were not terribly low, but we've seen drastic decline since then. Deepwater sculpin, it's a somewhat similar story, perhaps a little bit more striking. We do see that the highest biomass densities occurred in the 1980s, and what we're looking at is a somewhat different pattern. There was no peak in biomass in the 2000s. We've simply seen a decrease since the mid to late 1990s, and again, we're at the lowest biomass densities ever observed in this survey. And then that brings us to round goby. I'm showing you a different type of plot here for round goby to try and get a point across, and as a segue, what I wanted to show here is that we have for each year a pretty high degree of uncertainty in the goby biomass density estimate, and that's a measure of uncertainty just in the locations that this survey does sample. This doesn't take into account or provide us any idea about the uncertainty that would be, impressed upon this situation when you account for where we're not sampling, rocky substrate, hard substrate, and that drives home for me one of the key points about this organism. As I mentioned earlier, I'm going to talk very briefly about some of the things that I think are going on with goby. There was a talk last March at this meeting by Randy Claremont that went into a lot more depth than I'm going to be able to cover today, and a lot of you are probably involved in some efforts to try and do a better job of understanding how many goby are actually present. So I'll say that we're hearing more and more that gobies are consumed by almost every predator in Lake Michigan. And we're even hearing from some people that they're being consumed by what we would historically consider non-predators. As one example, I've heard from Randy Claremont that he's been finding gobies in adult cisco stomachs caught during the summer. And that to me is pretty interesting. We also can say that gobies have had a negative impact on some native species. It's not so clear what impacts they're having on some of the species we assessed with the bottom trawl survey or the acoustic survey, but that is something that we need to get a better handle on, and one key element of that is understanding how many of these things there are. It's pretty difficult to sample them. Our traditional sampling approaches do not work well for rocky substrates, and those methods that do work better or are actually possible on rocky substrates are pretty untested in terms of which one's best and which one's most consistent, and that area is an area that is quite frankly one where we're looking at spending a lot of time and effort. I know that there are some folks at USGS who are actually looking for funding to try and do some research on better ways to sample goby, better ways to assess them in a variety of habitats. There are people also seeking funding to pursue research on their impact on the food web, impact on some native species like slimy sculpin. We know that we have issues with our estimates of the abundance of gobies because we have a situation in Lake Huron where there's an imbalance between how many get eaten and how many we think are actually there. And as a result, we really can't even begin to understand the full impact or role of this organism in the food web. So next, I'm going to try and put these Lakewide surveys we do each year in some kind of a context of each other and the bigger picture. One of the questions is, are our survey results always identical? And the answer to that is no. We tend to consider these surveys we do, the bottom trawl survey and the acoustic survey, as complementary to one another. In other words, we need both surveys to get an adequate picture of what's going on. And as a result, we're pretty confident that the work we're doing with these two surveys is pretty informative. Just to give you an example of how things have differed at times between these two surveys, this plot shows the box plot for alewife, bloater, and rainbow smelt. And the species are on the x-axis, and the biomass density on the y-axis, and the different colors represent the two surveys. This is for the reporting period that I presented here, 2010 to 2015. And what you can see is the acoustic survey's been, over the past several years, providing us quite a bit higher biomass density estimates for alewife than the bottom trawl survey has. But for bloater and rainbow smelt, there's much more similarity or overlap. This is something that can change through time, too, depending on a variety of factors. Another question that I thought of and care about was, do the surveys tell us the same thing in general? The answer to that question is yes. Prefish biomass, this is total prefish out there, is at an all-time low. To give you an example from the two surveys, this is the total biomass density from the acoustic survey. This is a little different from the plot I showed earlier in that I have added two data points from the 1980s that were collected by Ray Argyle, reported in one of his papers, just to give a sense of the stability of things in the 1990s. The 1980s were quite similar to the 1990s, and we can see that the period from 2001 onward is quite a bit lower. And even though there's enough variability to cause overlap in the confidence intervals, there's no doubt in my mind that this is just a huge change in fish biomass. There we go. You can see the same thing from the bottom trawl survey. This is total biomass density, and we get a slightly different picture because we've got a longer time series. There's fewer interruptions, really only one interruption in this time series, but we've basically been looking at declining total fish biomass since the bloater peak in 1989. And this, again, is a huge change. And we can conclude that not only are these two surveys telling us the same thing, but if we look at another way we have of estimating the biomass of fish in the lake, this plot shows the most recent stock assessment model run estimate for alewife biomass in the lake, and we can see that we've gone from something on the order of close to 500 kilotons in the 1970s to under 40 in 2015, and that again is just a phenomenal change that I think is unprecedented. Maybe we're seeing this in Lake Huron too. I just don't think we have the same time series at our disposal right now to look at it quite this way. So finally, I'll try and draw some conclusions, and I'll say that as a way of repeating this, the surveys and the stock assessment model are showing us that prefish biomass is at an all-time low. We can say that the most recent time period, 2010 to 2015, is one marked by a couple of things that are not good for the alewife population. One is there's high mortality. There's been a pretty high level of consumption. And two, there's really only been one strong year class, and that was in 2010. There was one, what I would call average year class in 2012. I don't have time to show you much about that today, but there's information about it in a report that's out on the table. Basically what we're seeing is the alewife population is dominated by the 2012 year class, and there's pretty low contributions from any other year class out there. I think we had a couple of age 6 fish at most. So I can say that there's a broader age composition of this population than there was in Lake Huron when the fish in Lake Huron collapsed. But I will also say that I think the Lake Huron surveys should serve as an example. What we saw there is in 2004, I caught 2 alewife in the Lakewide survey of Lake Huron. That was the fewest alewife I'd caught in any effort I've ever made. I was just floored. I mean, I couldn't believe that you guys are telling me this is an alewife lake. That was my second year here. But since that time, I've had the opportunity to survey alewife through 2 population collapses in 2 different lakes. So I'm pretty much a believer. When we don't see very many in the survey, there's not very many present. Finally, I think it's clear in Lake Michigan, other species are not yet replacing alewife. In Lake Huron, we're seeing some native species, bloater for example, becoming more dominant in the fish community. We've seen, I think, an increase in the number of Cisco that we've been capturing in the Lakewide acoustic survey in Lake Huron. We still don't catch a lot. Something like an average of 10 or 12 per year, even though that average is not a good thing, really good measure, because some years we catch 25 little ones and in other years we catch 2, But we're getting them. I will say Dale Hansen managed to snag 3 adult Cisco in a northern Lake Huron, or northern Lake Michigan survey in the late August period, which is kind of a first. I didn't get to talk about that much today either. And finally, round Gobies status and their role remain highly uncertain. This is an organism that we really need to focus on if we want to understand what's going on in these food webs, because they're really being hammered by a lot of fish. With that, I'd be happy to take any questions.